Okay, before I was so rudely interrupted by the 15-minute timer that I did not know existed, let's continue. Magnesium and chlorine. So we know chlorine is diatomic. Okay, two elements, they're going to go together as a compound. This is going to be a simple synthesis reaction. And so magnesium and chlorine, well, magnesium's 2 plus and chlorine is 1 minus, so it's MgCl2, no balancing on this one. And you're just going to say they make magnesium chloride. Mercury 1 carbonate decomposes. So once again, we know this is a decomp. All right. And so in looking at this, Mercury 1, that tells me Mercury's charge is 1 plus. Carbonate is CO3 and it's 2 minus, so the 2 goes here. So there's my Mercury 1 carbonate. Carbonates break down into metallic oxides and carbon dioxide. And so I'm going to put the CO2 here. And then my metallic oxide, well, that's going to be mercury and oxygen. The oxidation state of the charge of mercury is not going to change. And so this one's already balanced. I'm going to go ahead and just write mercury 1 oxide plus carbon dioxide. Aluminum plus fluorine. Once again, we have two lone elements, and so this is going to be a synthesis. So we have aluminum, and then fluorine has to be diatomic. When they combine, aluminum's charge is 3 plus, so it becomes AlF3. In order to balance this, I'm going to flop a 2 here and a 3 here to balance the fluorine, 2 in front of the aluminum. And so they just make aluminum fluoride. Potassium, metal, and oxygen gas. Once again, the word metal, you don't need it. It's just there to confuse you. Potassium is a metal. It's just telling you what type of element it is. Same thing with the gas. So it's just potassium and oxygen. So it's another synthesis. Potassium is K. Oxygen's O2. Okay, because it's diatomic. Potassium's 1 plus and oxygen's 2 minus, so it's K2O. In order to balance this, you're going to put a 2 there to balance the oxygen, a 4 in front of the potassium. And so all I have to do is simply name the product. Potassium oxide. Sodium carbonate. So once again, just one element that's a reactant. So this is going to be a decomposition. I look at carbonates, and once again, they turn into a metallic oxide and carbon dioxide. Sodium is 1 plus. Carbonate's CO3 and it's 2 minus, so it's Na2CO3. The carbon dioxide is just CO2, and then the metallic oxide is sodium oxide. There's my sodium oxide. This one happens to already be balanced. Sodium oxide plus carbon dioxide. Mercury 2 oxide. So this is going to be the first one that's a simple decomp because it's not a carbonate, it's not a hydroxide, it's not a chlorate. So first I have to write the formula. If mercury's 2 plus and oxygen is 2 minus, it's HGO. Right? And so it's just going to fall apart into two separate elements. It's going to turn into mercury and oxygen. Oxygen has to be O2 because it's diatomic. 2 here, we're good. And then just write mercury, that's an E, plus oxygen. Iron 3 plus copper 2 nitrate. The only reason why the 3 is there is that we know what charge iron is going to have on the other side. It really has no meaning. Don't put the 3 plus on the iron sitting over here. It's just iron. Okay? So there's your iron. And then copper 2 nitrate is going to look like this. Here's nitrate. The 2 goes down there from the charge of the copper. This is going to be a single replacement because we have a lone element and a compound. Iron is going to try to replace the copper, because like replaces like, metals replace metals. And so because iron is going to be 3 because of this 3, it's going to be Fe NO3 parentheses 3, and then copper gets kicked out. It's by itself. Okay, in order to balance this guy, you're going to put a 2 here and a 3 here. 3 in front of the copper, 2 in front of the iron. So all we have to do now is name it iron, Roman numeral 3, nitrate, plus copper. Single replacement. Chlorine gas and iron 3 bromide. Once again, we have an element and a compound. It's going to be single replacement. Chlorine's Brinkelhoff. Iron 3 bromide. Here's your iron. Bromine is 1 minus, so it's FeBr3. Like replaces like. And so it's going to be iron 3 chloride plus bromine, which is also diatomic. Let's see, to balance this, let's put a 2 here and a 3 here. We're going to put a 2 here and a 3 here. So 6 chlorines on both sides, 6 bromines, 2 iron. Now all we have to do is name it iron, Roman numeral 3 chloride plus bromine. Aluminum hydroxide and magnesium chloride. Double replacement because I have 2 compounds. So aluminum hydroxide, aluminum is always 3 plus and hydroxide is 1 minus, so it's AlOH3. Magnesium chloride, magnesium is 2 and chlorine is 1, so it's MgCl2. Once again, we're going to switch dance partners. Aluminum is going to go with the chloride, AlCl3. What's left over? Magnesium hydroxide, MgOH parentheses 2. In order to balance this thing, I think we're going to put a 3 here and a 2 here. We'll put a 2 here and a 3 here, and it should be good. 2, 3, 2, 3. And name them aluminum chloride, plus magnesium, hydroxide. Last but not least, we have phosphoric acid with cobalt-3 carbonate. So once again, we have 2 compounds. It's going to be a double replacement. So here's my phosphoric acid. Cobalt-3 carbonate, that tells me cobalt's charge in this instance is 3 plus. Carbonate is CO3 and it's 2 minus. So the 2 goes there, 3 goes here. They're going to switch dance partners. The hydrogen is going to go with the carbonate, so hydrogen carbonate or carbonic acid. 2 goes here, CO3. Cobalt is 3 plus and phosphate is 3 minus, so it's just COPO4. Alright, let's take a look here. In order to balance this guy, let's do the carbonates. Let's put a 3 here. That's going to make 3 carbonates on both sides. I have a total of 6 hydrogen over there, so I got to put a 2 here, put a 2 here, and that balances both the cobalt and the phosphate. 2, 1, 3, 2. All I have to do now is name these. You could say hydrogen carbonate. It's carbonic acid. You wouldn't be expected to know that yet. Carbonic acid plus, and we're going to say cobalt, and then Roman numeral 3, phosphate.